In April, after months of eerie silence, Voyager 1 sent a faint signal back from 15 billion miles away, a whisper from the edge of the unknown. It wasn't just a status ping or a routine check-in. What it carried was a revelation that shook the foundations of what we thought we knew about the cosmos. Voyager 1, humanity's farthest traveler, has crossed into the interstellar void, and what it's finding out there isn't just unexpected. It's rewriting the very rules of the universe beyond our sun. The data streaming back isn't just numbers or graphs. It's a glimpse into a realm so alien, so intricate, that it challenges our deepest assumptions about the space between stars. This isn't a story of distant planets or familiar skies. This is about the raw, uncharted fabric of the galaxy itself, and it's far stranger than we ever imagined. Voyager 1, launched nearly half a century ago, became the first human-made object to breach the heliopause, the boundary where the sun's influence fades and the interstellar medium begins. It's no longer in our solar system's protective cocoon. It's out there, alone, in the vastness where stars are born and die. After a heart-stopping communications blackout that left scientists scrambling, the spacecraft's signal returned, faint but alive, carrying data that's forcing us to rethink the very nature of the galaxy. The interstellar medium, once thought to be a sparse, uniform void, is anything but. Voyager's instruments are detecting patterns, structures, and forces that defy every model we've built. This isn't just a scientific milestone. It's a confrontation with the unknown, a moment where the universe reveals it plays by rules we're only beginning to grasp. What Voyager is finding out there is nothing short of astonishing. The interstellar medium isn't a featureless expanse. It's a dynamic living tapestry of magnetic fields, plasma waves, and cosmic radiation. The first shock came from the magnetometer, which picked up an interstellar magnetic field twisted at an angle far sharper than anyone predicted. This isn't a minor misalignment. It suggests the galaxy's magnetic structure is far more complex than our theories allowed, possibly shaped by ancient cataclysms or unseen forces weaving through the cosmos. These fields aren't static. They twist, fold, and reconnect, creating turbulent zones that ripple across vast distances. Voyager may be brushing against a galactic boundary, a place where magnetic forces sculpt the invisible architecture of the Milky Way. Then there's the plasma. Voyager's instruments have detected sudden spikes in density, like waves crashing through an unseen ocean. These aren't random blips. They're structured, coherent, hinting at shock fronts from supernovae that exploded long before humanity existed. These ancient explosions left scars in the interstellar medium, and Voyager is sailing through their echoes. The plasma wave instrument has also picked up something even more haunting, a constant, low-frequency hum, a vibration that permeates the space between stars. This isn't silence, it's the galaxy breathing, a cosmic rhythm that suggests the interstellar medium is alive with activity. Picture it, Voyager isn't drifting through emptiness. It's navigating a sea of invisible currents, where every layer reveals new textures, new rules. What's most striking is how organized this interstellar realm is. Scientists expected a diffuse scattering of particles, a cosmic desert. Instead, Voyager is uncovering distinct regions, zones where plasma density spikes, where magnetic fields shift, where cosmic rays surge. It's like sailing through different climates in an interstellar ocean, each with its own character. Some regions are dense, others sparse. Some are turbulent, others calm. This structured complexity hints at a galaxy far more dynamic than we imagined, where invisible forces shape pathways and barriers across light years. Voyager isn't just collecting data, it's sketching the first outlines of a galactic landscape we never knew existed. The cosmic rays tell their own story. As Voyager crossed the heliopause, it detected an abrupt spike in high-energy particles, accelerated to near-light speed by distant supernovae and black holes. These rays bombard the spacecraft at rates far higher than anything inside our solar system. The transition wasn't gradual. It was a sharp threshold, as if Voyager stepped through a cosmic doorway. This reveals something profound. Our sun's heliosphere is a shield, protecting Earth from a radiation environment far harsher than we realized. We live in a cosmic sanctuary, a bubble carved out by the sun's magnetic field. But out there, beyond that bubble, the galaxy is a storm of energy, and Voyager is sailing through it. Even more intriguing, the cosmic rays aren't uniform. Voyager's detectors have measured subtle variations, suggesting the interstellar medium has channels, natural corridors where particles flow like rivers. These could be the imprints of ancient stellar explosions or the edges of galactic clouds. Some scientists now speculate Voyager might be skirting the boundary of a low-density void, a vast cavity carved by supernovae millions of years ago. Others wonder if these patterns trace a larger galactic structure, a network of magnetic highways that guide cosmic rays across the Milky Way. This isn't just local weather, it's a glimpse into the galaxy's deep history, a map of events that shaped our stellar neighborhood long before the sun was born. The communications blackout that gripped Voyager in late 2023 was a stark reminder of how fragile this mission is. For months, the spacecraft sent only garbled signals, its voice lost across 15 billion miles. Engineers traced the problem to a corrupted memory chip, likely struck by one of the very cosmic rays Voyager was studying. The irony is almost poetic. The spacecraft, sent to explore the interstellar medium, was wounded by its raw power. Fixing it was a feat of ingenuity. Engineers rewrote code for 1970s hardware, rerouting functions to back up memory across a distance so vast that signals take nearly a day to travel round trip. Imagine performing surgery on a machine older than most of its operators, with no room for error across a gulf of space. By April 2024, Voyager's signal stabilized, and its instruments began singing again, each one adding a new note to the symphony of interstellar discovery. This rescue wasn't just about saving a spacecraft. It was about preserving humanity's only direct connection to the space beyond our sun. Every data packet Voyager sends back is a treasure, a snapshot of a realm no telescope can fully capture. The magnetometer, plasma wave system, and remaining instruments are still active, painting a picture of an interstellar environment that's both chaotic and structured. The data suggests the galaxy isn't a static backdrop, but a dynamic system, with currents and boundaries that shift over eons. Voyager is giving us our first real-time glimpse of this cosmic machinery, and it's reshaping how we see our place in the universe. What Voyager is doing goes beyond science. It's crafting a map of the unknown. Each measurement is a data point in a new kind of cartography, a 3D model of the Milky Way's magnetic and radiation zones. These aren't abstract theories. They're anchor points for understanding the galaxy's invisible skeleton. The cosmic ray gradients, plasma density shifts, and magnetic field twists are helping scientists build a navigational chart of interstellar space. Think of it as a cosmic GPS, a guide to the forces that govern the void between stars. This map could one day steer future spacecraft, shielding them from radiation or guiding them through safer corridors. It's not just about exploration. It's about survival in a galaxy that's far more intense than we realized. The implications stretch even further. The structures Voyager is detecting, magnetic fields, plasma ripples, radiation channels, might influence how stars form. Magnetic fields can funnel cosmic material into dense pockets, sparking the birth of new suns. The density shifts Voyager measures could mark the edges of interstellar clouds, where gravity begins to weave the raw stuff of the galaxy into stars and planets. This isn't just about mapping the present. It's about understanding the processes that built the Milky Way over billions of years. Voyager's data is a window into the galaxy's past, present, and future, all captured by a machine that's been traveling for nearly 5 decades. The interstellar medium, as Voyager reveals, is less like a void and more like a cosmic ocean, complete with currents, tides, and storms. Since crossing the heliopause, the spacecraft has passed through at least 3 distinct regions. Cloudlets where plasma density spikes by factors of 2 or 3. These aren't random fluctuations. They're structured with clear boundaries, like weather fronts in space. Scientists now believe our sun is moving through a larger structure called the local interstellar cloud, a diffuse region within an even vaster cavity known as the local bubble. This bubble, carved by ancient supernovae, stretches hundreds of light years, and Voyager is helping define its edges. These findings ripple back to Earth in ways we're only beginning to understand. The interstellar medium's density and radiation levels could influence our planet over cosmic timescales. As the solar system drifts through the galaxy at 450,000 miles per hour, it encounters different interstellar environments, each with its own radiation profile. These shifts could subtly alter Earth's exposure to cosmic rays, potentially affecting climate patterns or even the mutation rates of life itself. Voyager is showing us that the boundary of our solar system isn't a clean edge, but a turbulent frontier, a place where the galaxy's forces collide with the sun's protective bubble. This interstellar weather is anything but static. The boundaries Voyager crosses shift and evolve, shaped by the sun's motion through the galaxy. Plasma ripples and magnetic turbulence suggest a dynamic environment, one that's constantly reshaping itself. Voyager's instruments are capturing these changes in real time, revealing a cosmic landscape that's not just textured, but alive with motion. Each new measurement refines our understanding, peeling back another layer of the galaxy's hidden structure. This isn't the empty space of old textbooks. It's a realm of invisible forces, sculpted by events that happened millions of years ago. Voyager's journey is more than a scientific mission. It's a testament to human ambition. Launched in 1977, it was meant to explore Jupiter and Saturn, yet it's still sending back data from beyond the heliopause. Its instruments, built with technology from an era of slide rules and punch cards, have outlasted their creators' wildest expectations. In September 2024, engineers performed a daring thruster swap to keep Voyager's antenna pointed at Earth, bypassing clogged fuel lines that threatened to end the mission. In early 2025, facing dwindling power, they made the heartbreaking choice to shut down the cosmic ray detector, sacrificing one instrument to extend the other's lives. Every day Voyager operates is a gift, a fleeting chance to glimpse the galaxy's secrets. But Voyager's story doesn't end when its power fades. This small spacecraft will drift through the cosmos for millennia, carrying a piece of humanity with it. The golden record, etched with sounds, music, greetings in 55 languages, and 116 images, is a time capsule built to last a billion years. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of a star called Gliese 445, a fleeting encounter by cosmic standards. Long after Earth's continents have shifted, long after our cities have crumbled, this record will endure, a silent ambassador of a species that dared to reach beyond its star. Voyager isn't just a probe, it's a monument, perhaps the most enduring mark humanity will ever leave on the universe. What has Voyager truly found out there, 15 billion miles from home? It's not aliens or wormholes, but something far more real and profound. The interstellar medium is a structured, dynamic realm, woven with magnetic fields, plasma waves, and radiation currents. It's a place of boundaries and layers, shaped by ancient supernovae and galactic forces we're only beginning to understand. The heliopause isn't a clean break, but a turbulent frontier, where the sun's influence fades into a cosmic storm. The magnetic fields twist unexpectedly, the plasma hums with unseen energy, and the cosmic rays reveal a galaxy that's both protective and perilous. The most humbling discovery might be this: our solar system is a fragile oasis, shielded by the sun's heliosphere, from a galaxy that's far more intense than we imagine. Earth exists in a delicate balance, protected from the cosmic radiation that Voyager now endures. This isn't just about science. It's about our place in the universe, a reminder of how small yet resilient we are. Voyager has reached the other side, and what it's found is a galaxy that's alive, complex, and full of surprises. It's not the emptiness we expected. It's a cosmic tapestry, and we're only beginning to trace its threads. For those who crave the details, here's the technical backbone. Voyager 1 launched in 1977, designed for a 5-year mission to Jupiter and Saturn. It reached the heliopause in 2012, 11 billion miles from Earth, becoming the first object to enter interstellar space. Its suite of instruments, magnetometer, plasma wave system, and others, was built for planetary exploration, but has proven astonishingly versatile. The spacecraft runs on just 23 watts, its signals taking over 22 hours to reach Earth. Every transmission is a miracle of engineering, a testament to a design that's endured for nearly 5 decades. Voyager's data is humanity's only direct sample of the interstellar medium, and each byte is a step toward mapping the galaxy's unseen structure. What lies ahead for Voyager? Its power will fade in a few years, but its journey will continue. It's not just mapping the present, it's laying the foundation for future exploration. The magnetic fields, plasma boundaries, and radiation zones it's charting could guide spacecraft or protect astronauts venturing beyond our sun. The galaxy isn't a void, it's a landscape, and Voyager is its first cartographer. This is real science, unfolding in real time, and it's changing how we see the cosmos. The universe isn't what we thought. It's richer, stranger, and more alive than we ever dreamed.